So here we have a fairly simple data set and very appropriate for an independent t-test. This is where we have two groups that are independent of each other, and we're looking for the differences between those two groups in a dependent variable. So here we've got two groups of cattle. This is not one of those before and after tests. This is separate groups. Here we've got a measurement of plasma glucose in those cattle, and we've got null hypothesis is that there's no difference. First thing is to look at this Excel sheet. We see the data in what we call a long format. In the long format, instead of having a group 1 column and a group 2 column, instead we have a single factor column, a grouping column here. So we've got group 1 cows and we've got group 2 cows there, and then we have a separate dependent variables column here. Some statistics packages allow you to have both formats. For Jamovi, we need the long format for the independent t-test, and for the paired t-test, we're going to use the other wide format that we'll see in another video. So here we've got our single row with our column headings, simple words. Ideally, we don't want to have two words here. We just want to have one text string. We might use something like this. We might use an underscore if we really needed to make a single text string with two words in it. But actually, keeping things simple is better. So I'm going to just call it glucose. So I'm going to copy these into Jamovi. So here, we're going to take that and right-click copy or Control-C, and we're going to copy that. We open the Jamovi program, and we've got our spreadsheet looking like this. Now, we could just have copied the data in. Actually, for speed, I've copied the data and the column titles. I just wanted to show you something there. So if I right-click here and paste here, I can't paste into the column titles above here. But I could do and take the data in various ways. But here, what I'm going to show you is if I obviously that first row is redundant. I don't want that in the data set. That's going to confuse the statistics later on. But it is a helpful reminder as to what to call my columns. If I double click column A, it comes up with A. And actually, I can take this group and I can copy that. I can Control-C on the keyboard and I can paste it there. Or I could have just written it. And then that's changed that. This is nominal data. These are factor levels, group 1 and group 2. The level's already sorted. It's text, so everything's fine there. So if I go to column B, these are the numbers. These are decimal places. So this is not nominal data. This is continuous data. And here, I could have selected continuous data to be a whole number, integer, or decimal, or even a text label. But of course, it's a decimal. So that's right. It's deleted the glucose one, so I should have actually copied that first. But I could just write or type glucose here, and then we're all good. Okay. So and then I click somewhere else, and then I've got these. But you notice I've got row 1 is still redundant because I copied those titles across 2, and now I need to delete them for any statistics to happen. Notice I could have just copied the data and saved that problem. Okay. So I'm ready for statistics. I want to just make this go away. I'll hit that arrow, it hides that. Now I'm ready for my analysis. And that really is simple. In Jamovi, I'm in the analyses menu at the top. I click the t-tests, and I've got a choice of 3. And generally, we'll either want the independent t-test or the repeated measures kind of paired t-test for before and after, or anything that's a direct comparison. And here I'm going independent samples t-test. Brings up this window, and it's all ready to fill in my table. I like Jamovi for that. So here, dependent variables, well, that's my outcome. Here we've got a nice little rule assigned to show the continuous data. Click on there, move it across there. And glucose is already in here. Grouping variable, well, that's easy, it's a group. I'm going to move that across too. And it's done my t-test already. Here, I've done a student's t-test. And it's there's my actual test statistic. That is my degrees of freedom. And there is my probability, my p-value. So the chance of the null hypothesis is the hypothesis underneath. The group 1 is different from group, and it's the same as group 2. And the alternative hypothesis is that there's a difference, but the null hypothesis is that they're the same. The chance of the null hypothesis being true is 73% or 0.73. But not enough for your thesis, not enough for your analysis. So there's other things to check. First one is that we've actually got two different types of t-test. We've got an equal variance t-test, which is the default, but we also have an unequal variance t-test, which is also known as a Welch's t-test. So I'm going to click the homogeneity test, which looks at the variation in the two samples here and compares them. Now, if this value comes up as significant, it's saying that this is a significant departure from equal variance, and therefore you would put a tick in the Welch's box. But here, we're pretty certain, 99.4% confident, that the variances are the same. That's what Levine's test tells us. So we can progress as we are. If this was less than 0.05, we'd put a tick in this Welch's box. Okay, what do we do next? Well, actually, it's quite useful to see the descriptive statistics. So here we're going to click on this descriptive statistics. And there's a lovely table that comes up that's going to be useful later on. Here, group 1 has a mean of 71.0. Group 2 has a mean of 71.9. So group 2 has the higher mean. Are they significantly different? No, they are not. The p-value up here says that they are 73% chance of them being the same, and that's nowhere near our threshold for significance. That's still quite useful. The last one I want to highlight your attention to is that this is depending on how you want to present your tables, but sometimes it's useful to have a value called the standard error of difference, which compares the differences between the two. And when I click mean difference, that does a very simple calculation. It gives you a very precise difference. Minus 0.860 is obviously actually a more accurate version of 71.0, take away 71.9. But the standard error of difference here, 2.46, that's what I've suggested on your how-to sheet to include as a very tidy way of presenting your variance figures. Okay, so I can just take all of this, click hold up, right-click the table. I'm going to export the table, export all of it actually. I'm going to copy that. I've copied it to the clipboard and go back to Excel. I can right-click and I can paste it here, and there's all my tables. Actually, you're better off turning this round so you have the group 1 and group 2 as columns here, but there's all the detail you need for filling in your t-test results. And of course, if you had multiple outcomes, so you had plasma glucose, maybe you had a protein figure, maybe you had a packed cell volume figure, you could put those all in the same table as different rows. That'd be really nice and tidy. That's your independent t-test. Thank you for watching.